this video, we will take a closer look at the composite steel beam module. We will examine the various input and output data, as well as discuss the module's engineering capabilities. We first start by clicking on the Add button and navigating to the Beams tab. You can see the extensive variety of beam modules that InnerCalc offers. Today, we're focusing on the composite steel beam module, so let's click on it. This module has the familiar layout that all of InnerCalc modules have. The input data is on the left-hand side, while the output results are displayed on the right-hand side. We will start with the General tab and we'll work our way through. First, let's give this calculation a name. Let's call it CBS1, which is short for Composite Steel Beam 1. Then, you can pick the preferred design methodology for the steel section. In this example, we will use the ASD design methodology. Next, we specify the Fy value as well as the modulus of elasticity value. In this case, Fy of 50 ksi and E of 29,000 ksi are appropriate. InnerCalc provides a great level of flexibility when specifying the allowable deflection ratios. You can specify a deflection ratio for each of these cases separately. A ratio for the pre-composite loading, a ratio for the transient loading, and lastly, a ratio for the final total loading. And in this case, we will change this to 240. Now that we have covered the basic entries, we can move forward with more input regarding the assembly itself. In this example, we have 3-inch concrete over 2-inch metal deck. This means total slab thickness is 5 inches. The effective width depends on the overall framing geometry as well as the adjacent framing members. Hence, InnerCalc cannot calculate this variable without knowing the full assembly. With that, the effective width needs to be a user input. However, if you click on this button, you will get this pop-up window that references the appropriate AISC provisions, as well as it guides you through the simple process of calculating the effective width. In our example, the beams are spaced at 8 feet on center, and the full span of the beam is 24 feet. Based on the AISC provisions, the effective width shall be 6 feet. Keep in mind, the effective width is not the same as the trib width. The beams are at 8 feet on center, hence the trib width is actually 8 feet. However, the effective width in our case is controlled by the span. That is following the 1/8 of the span value on each side. Hence, the effective width is used as 6 feet. So we click OK, and we update the effective width to 6 feet. InnerCalc can design a solid concrete slab that spans from a steel beam to another. However, in our example, we have 3-inch concrete over 2-inch metal deck. To implement this, we need to check this box. You can manually input your own deck profile geometry in case you have a non-traditional product. You can specify the height, pitch, and width at the top as well as the width at the bottom of the deck, and InnerCalc can perform the calculations for you. Alternatively, you can pick from the library of metal decks InnerCalc has by simply clicking on this button. The decks are listed and grouped by the manufacturers. You can see some historical products as well as currently available products. For our example, we will pick Volcraft 2 VLI deck. The corresponding rib measurements are automatically populated for you based on the product you selected. Moving on, you can pick the deck orientation with respect to the beam. We will keep the deck direction as perpendicular to the beam. However, the user has the option to pick either parallel or mixed if it is in a transition zone. Additionally, we can specify if the construction is shored or unshored. If the construction is shored, then you no longer need to examine the pre-composite state of the assembly, since adequate shoring will be provided. However, the more common construction method is unshored. This means we have to evaluate the pre-composite state for the loads applied before the concrete cures, meaning before the composite action is achieved. We will move forward with our design as unshored. If you like to learn more or have any questions, you can visit our website innercalc.com or send us an email at support@innercalc.com. Thank you for watching.